You've been driving to and from school every day.
Oh gosh. Heaven help the rest of us. Okay, so today we are multiplying and dividing. Yes?
Do we just like
30 minutes.
You can keep them, throw them out. I would not throw out your quizzes until after you verified that I actually put them in grade link correctly. Okay, so today we are multiplying and dividing rationals. Multiplying and dividing rationals. Alright, so you probably already have memorized, like, if I multiply by a negative, I get a negative, right? And if I multiply two negatives, I get a positive, okay? So we'll want to keep that. Same thing if we're dividing. So if I had like negative 20 divided by negative 4, I would get positive 5.
Oh, just kidding.
So it's all good. And if we had, say, a positive divided by a negative, we would get a negative. Okay, so just an example. So if we're multiplying and dividing, if the signs are the same, now we aren't going to say same sign sum, same signs, we get a positive, and if we have different signs, we get a negative. And I'm just going to demonstrate why with one example, and then we'll just keep that because I'm pretty sure you guys are good at it. Here's why. So if I had, say, 3 times negative 5, which I have something similar up here, that means 5 plus negative 5 plus negative 5. And then from when we did addition, we switched those to all negatives, same sign sum, so I add all those up and keep the sign. So that's why it works out that way, but you don't need to write it out. That's just the reason why this rule works. I'll give you a moment to write that down. Does anyone need more work on just these whole number types? Because we're going to hit those really, really fast and then spend our time on fractions mainly. Because fractions are what get us. We don't like fractions.
Who built it? Okay. It's not you.
Oh, fractions are amazing.
That's what you think.
Okay, do we have the gist of this down? Okay, so we'll go on. All right, so let's talk about multiplying fractions. Because fractions are rationals. And then we'll briefly do decimals. Those aren't as difficult. So let's say I have negative 2 and 3/5, and I'm going to multiply that by 1 and 4. I don't know. I don't want to do fifths.
Sure.
We'll do sevenths. Okay, have your calculator handy, because I made up these numbers, so bad things are going to happen. Okay, so the first thing is we want improper fractions. So how do I make these improper?
Multiply the denominator and add the numerator.
Yep, multiply the whole by the denominator, add it to the numerator, so we get negative 13 over 5. We just keep that negative times. Okay, again, we'll multiply and then add to our numerator, and we get 11 over 7. And then we'll check for cross cancel. And because I made up these numbers, there is no cross cancel. Cross canceling saves us the step of reducing. But we always want to reduce our fractions. And then we do top times top and bottom times bottom. So 13 times 11, according to your calculator, is
Negative 143.
and 5 times 7, 35. And that is fine. We can leave it improper. No need to make it mixed. We do need to reduce it, though, if possible.
So wait, if we cross cancel, we don't have to.
You probably will not need to reduce if you cross cancel. So we're going to do an example of that right now. Let's say we have this. That doesn't reduce. We'll make it negative, because why not? And let's do, we'll make this one negative because why not? And this one does have cross canceling. Now, if you don't see the cross canceling, that's okay. That just means you're going to have more reducing to do at the end. So cross cancel means I look crossways and I see if I could divide both numbers by the same thing. So I see my 10 and 5 and I can divide those both by, so that 10 is going to become a 2. And I want to remember my sign is negative, and this 5 is going to become a 1 because I divided those both by 5. Now you may not see the cross canceling here, but I can actually cross cancel the 34 and the 17. Those are both divisible by 17. So the 17 becomes a 1, and the 34, it is negative, but will become negative 2. So in the end, I have negative 2 times negative 2, which is positive 4. And if you didn't see that cross canceling, that just means at the end you're going to have some extra to do. Let's say we have negative 6 over 15 times, and sometimes even cross canceling, we still are going to have something left. 5 over 12. Okay. We cross cancel. What can we cross cancel? That'll be a negative 1 and a 2. And how about anything else? Yep, 5 and 15. So we get a 3 and a 1. Top times top. Bottom times bottom. And then I check to see if I can reduce that. Always check to see if you can reduce it. But the cross canceling will make that step probably not as necessary. Alright, so that's multiplying fractions. You ready to divide?
Yes.
Of course you are.
No.
Oh, do I need to go back to that? Dividing fractions. It's basically the same. We're going to go to KFC. We're going to keep. We're going to flip. And we're going to change to multiplication. The reason is because division is the inverse of multiplication. So if I flip the second fraction and switch, I'm using that inverse fact. So let's start with 1 and 1/3. And let's divide that by 2 and 1/2. So we're going to keep the, well, first we're going to need improper. We definitely need improper fractions. So I'm going to multiply and add. I get 4/3. And I'm going to divide that by 5/2. I'm going to keep the first fraction. I'm going to flip the second fraction and switch to multiplication. Keep, see keep, flip, and change to multiplication. Now I do top times top, bottom times bottom, nothing cross cancel. Okay. Let's see here. What should I do there?
Make the 2 1/2 an improper fraction.
Now what do we do?
Split the 5 and 2.
Yep. So we have negative 5/8, switch to multiplication, flip the 5 and 2. Every day. It's like he's like out to get math class, so he's going to mow.
I was about to say, is he like mowing dirt or something? Grass some dirt
Alright, so we're going to cross cancel. We can cross cancel the 8 and 2. Pay attention. So 4 and 1. We can cross cancel the 5s. Get negative 1 and 1. Top times top, bottom times bottom, and we're good. So that's dividing fractions. Now I'm going to teach you a little bit something right here that you probably don't need to know, but is really going to help you in case it does come up. And that is...
Oh, go back to this.
Oh, go back, go back. You good?
No. I'm trying to figure out. I don't know what happened with that little arrow.
Oh, as in, I'm doing this problem, but I ran out of space, so I moved it over here. So this would normally in your work would go below that.
But why is they 8? That's a 5. Okay, how'd you get the multi ones and that 4?
Okay, so the 8 cross cancels with the 2.
Wait. I see. Thanks.
Okay. All right. So now complex fractions. Basically, complex fractions are fractions in fractions. For you this year, the easiest way to think of this is division. So if I had 2/5 over 1 3/4. See, this is one big fraction, but I have a fraction here and a fraction here. The fraction bar means divide. So I just change it to a division problem. So I rewrite it as 2/5 divided by 1 3/4. Be good? So now, I just do all those steps with division. Change to improper. Keep flip change. And cross cancel possible, not possible. Check to reduce. Always check for reducing. I mean, this one doesn't. But always check that just to make sure. Now we need to talk about decimals. Hopefully you're good at these. We'll see.
No, not really.
Do we need that?
Yeah. Wait, am I? I like these.
All right, let's do multiplying decimals. This one, yeah, I'm hoping that we don't have to spend much time on it. There is a thing, many students mix up multiplying decimals with adding and subtracting decimals. When you add and subtract decimals, you have to line up the decimal points. That is not the case with multiplying. So let's say I have negative 5.3, and I'm not going to use a point here because that'll be confusing, times, let's do 1.24. Now what I like to do is no matter what order it's in, I take the number that has the most actual numbers and I put that one on top. And the one that has the least numbers, I put that on bottom. So I see that this one had 3 digits, the 5.3 that had 2 digits. I just find that easier, but it doesn't matter. You do the same thing. So we're going to multiply. And then basically, we're going to multiply and ignore the decimals for now. So we do 3 times 4 and get 12. I'll carry the 1. And we do 3 times 2 and get, add the 1, and I get a 7. And then 3 times 1 is 3. Now what do I need to do right here? Add a 0. And we aren't quite to the decimal yet. And now we do the 5. Now we added this 0 because we're in the tens place right now. Well, it's not really the tens place because we're ignoring the decimals, but you know what I mean. So 5 times 4 is 20. We carry a 2. Now I erase what I carried from before so I don't get confused. I'll just write over top of it in this case. 5 times 2 now is 10, plus the 2 is 12. Carry the 1. 5 times 1 is 5, add the 1, 6. And now I add these. See, these are called partial products. And I'm going to have to add them to get my product. Anyone know what these are called? What are these called when we're multiplying? They're numbers. Sometimes they're called multiplicans. Multiplicans.
What?
I can't even say it.
Multiplicans?
Multiplicans. But we will call them factors. Because then that's going to agree with what we do earlier in the year. Earlier in the year? What do I mean? Going back in time? I mean later in the year. So we add these. Some of you are already like, I know what to do, Mr. K. Now, where do I put my decimal point? I count all the decimal places I have. I have how many of them?
3.
So starting from the beginning, I count 3. And there's my answer.
Oh wait, you forgot the negative.
And it's a negative. Thank you, Meredith. Good job. Good catch. All right, let's do one more. So which of those would we recommend to put on the top?
0.0.
Yeah, because I have more digits there. So I multiply these, and I made it simple enough. I get 36. But how many decimal places do I need?
5.
Need 5 places. Okay, so counting from the right, I need to annex some zeros here. So make sure you count carefully. 1, 2, 3, 4, 5. Okay? You might even put a 0 in front of that just to emphasize, but you don't have to. All right, so that's that by hand. Dividing them. Ugh.
I hate this part.
Everyone hates this part. Decimal division.
I don't even know if I know how to
And I'm not going to do a lot of examples of it. I just want us to get the general gist, and we can work on it and not have it be part of this little video. But let's say I have 3.24, and I'm going to divide that by 1.6. Now, sometimes you're going to have repeating decimals. You need to learn to recognize when it's repeating. Sometimes you have terminating. And sometimes you are asked to round. So make sure it means it ends. Terminating means it ends. Sometimes you are asked to round or estimate. So you need to read the directions, make sure that, because sometimes it happens like someone comes up to me and inevitably says, this goes on forever, Mr. K, and then I say, read the directions, and it says round. And then you've done all that dividing for nothing. All right, so this second number is called our divisor, this thing we're dividing by. And this would be my dividend. So when I put it inside the house, the dividend goes in the house. And the divisor goes on the outside of the house because it's rejected. It's the dog. It's been chained up. And the answer is the quotient. All right, so we're going to try to divide as if there weren't decimals. So what we're going to do is we count, we see this decimal in the divisor, and we're going to move it over, and we're going to put a little caret right there. And I moved it one time, so I moved this decimal in the dividend one time, and I'm going to bring it up right away. It's a caret.
What kind of carrot should you eat? Bring in.
This is not a carrot that you would eat.
Oh.
Okay, so, just by irony, I actually made this so it works out nice at the beginning. But that doesn't always happen. I estimate how many times it would go into 3, 0 times. I don't need to write anything, so now I'm at 32. 16 goes into 32 twice. So now I divide. Oops. I divide, that's the step I just did. I multiply. I subtract. I compare. And I bring down. Okay? So where on multiply step we get 32. We subtract, get 0. Compare, make sure that the 0 is less than 16, because if it's not, then that means there's an error. Bring down the 4. Okay? Now I divide. Well, 16 doesn't go into 4. So what do I write right here? And that because of this decimal point, that's going to be important that I have that. So what do I do? I need to add a 0 and bring it down, right? So now I'm at 40. And I'll just use this as a hint, 2 again.
Really? Oh, yeah.
Because 32. I have 8, add a 0, bring it down, 80. And do you get the point? 5 times maybe? And then that one terminated. So that's the answer.
How about we don't do any that repeat.
Any?
Yeah, I agree with him.
Um,
Okay, we'll do this here.
that's good. I think that's good for today. So we'll stop right there.